Philippine Society of Mechanical Engineers Technological Institute of the Philippines Student Unit, Manila. Philippine Society of Mechanical Engineers Technological University of the Philippines Student Unit. Philippine Society of Mechanical Engineers Camarines Norte State College Student Unit.
Philippine Society of Mechanical Engineers Colegio de Muntinlupa Student Unit. Philippine Society of Mechanical Engineers Bicol University Student Unit. Philippine Society of Mechanical Engineers Lyceum of the Philippines University Cavite Student Chapter. Philippine Society of Mechanical Engineers National University Student Unit. Philippine Society of Mechanical Engineers Pamantasan ng Lungsod ng Maynila Student Unit. Philippine Society of Mechanical Engineers Pangasinan State University Student Unit.
Philippine Society of Mechanical Engineers PUP Student Unit. Philippine Society of Mechanical Engineers Sorsogon State University Student Unit Sorsogon Chapter. Philippine Society of Mechanical Engineers Tarlac State University Student Chapter. Philippine Society of Mechanical Engineers University of Batangas Student Chapter. UP Geodetic Engineering Club. Philippine Society of Mechanical Engineers Sorsogon State University Student Unit Sorsogon Chapter. And a special thanks to UP Mining Metallurgical and Materials Engineering Association and Corporation.
I am Nathaniel Beaver A. Mendoza from St. Louis University. I am here to cheer and encourage our next board exams takers. Alam ko, marami dyan ang natatakot, nagdadalawang isip, napanghihinaan ng loob. I would like to say that all of those are valid. Totoo yan, naranasan ko rin yan nung una. But, don't let it eat away all of your time. Walang mangyayari kung palagi tayong magpapaanino sa mga negative thoughts natin. Kailangan natin kumilos and make the best of our time if you really want to succeed. Don't wish for it, make it happen. O kaya, nasa Diyos ang awa, nasa tao ang gawa. Kung tips sa review ang kailangan nyo, sabi ko, magkaroon kayo ng time management. Si Prime kasi araw-araw yung may lecture, araw-araw may isosolve, yun. Huwag rin kayong sana ma-overwhelm sa program ng Prime. Kasi talagang kailangan yan. Marami pa sana akong gustong sabihin, pero I leave that for you to discover. Lalo sa techniques, tuturo yan lahat ng Prime sa inyo. Magaling silang magturo. So anyway, gusto ko sanang magpasalamat sa pamilya ko, sa kanilang walang tigil na suporta, sa SLU ME Department at Prime Review na ibinuhos lahat ng knowledge at wisdom sa amin para mapagtagumpayan itong board exams. And most importantly, kay God na nag-guide sa atin. Thank you, God bless, lakad matatag.
Ako po si Christian Justin Sese, and I'm here to tell you how did I manage to get here even though na pandemic tapos puro online po yung review natin. Marami pong factors na consider, and malaki pong factor talaga na tumulong is yung Prime Review Center with the help of LearnHub PH app. As we all know, sobrang dami kailangan pag-aralan sa board exam, and from experience, so as much as possible, memorize mo lahat ng formulas, concepts, and elements. But Prime Review Center was able to cover this. We were able to tackle these major concepts, elements, and formulas in a very systematic pacing. Tapos, yung mga calculator techniques, shortcuts na formulas, in different kinds of subjects, natutunan ko lang sila dito actually, pero yung Prime Review Center talaga, binigay nila, hindi sila selfish. We also notice yung mga videos na ina-upload nila, sobrang detailed. Like, matututo ka talaga, like step-by-step solution, ibibigay nila. Yung mga problems na sobrang hirap na parang andali lang kapag sinolve, ibibigay nila. Yung pag nakakita ka ng ganitong problem, paano isosolve to, anong unang gagawin, di-discuss nila kung paano. Yung mga shortcuts, tips, and kung paano isosolve yung ganitong problem, di-discuss din nila doon. And kikita mo talaga na yung mga instructors and teachers na nagtuturo doon sa voiceover ng video, experience talaga. And sobrang dami namin natutunan sa kanila. And Prime Review made this possible and we are very grateful kasi bumibilis kami mag-solve na dati parang 5 minutes per problem, parang 2 minutes na lang ngayon or 1 minute even. Sundan yung program ng Prime. I was able to make it. Kaya we are very grateful for them teaching us.
Ang ating pong review ay online. At kung tayo man po ay may pangamba dahil dito, sana po alisin natin ang anumang pag-aalinlangan sapagkat si Prime naman po ay ibibigay lahat ng ating kailangan para tayo ay maging handa sa darating na eksaminasyon. Ganyan din naman po ako nung kami ay nag-review ng online na may pag-aalinlangan. Ngunit sa awa ng Diyos, sa tulong ng Prime, at sa pagsisikap, tayo po ay nakapasa. Which is, yun naman po ang gusto nating lahat. So, magtiwala lang po tayo and do our very best during the review. At tinitiyak ko po sa inyo na after ng ating review and refresher dito, ay sapat ang ating kakayahan para sa ating darating na board exam. Good luck, God bless, and have a nice day.
Okay, so good day sa inyo lahat. Ako pala si Engineer Marvin Ferrer, ang top 4 ng last mechanical engineering board exam sa held noong August 2021. And andito kami para ibahagi sa inyo yung mga kung paano nakatulong ito si Prime Review Center na nga dahil sa pandemics, nag-online review na lang tayo ngayon. So unang-una dito is napaka-flexible ng pag-review. Kung gusto mong mag-review ng gabi, pwede. Kung gusto mong mag-review sa Starbucks, pwede. Kasi pwede mong i-download or kunwari, basta may wifi ka, pwede mong panoorin at sagutan yung mga assessment, mga videos, anytime, anywhere na gusto mo. Besides dito, syempre, napakarami mga formula, mga LMS na kayo may memorize, diba? Dito, bibigyan ka rin ng mga tips and tricks, mga techniques kung paano mas ma-memorize yung mga kailangan mong kabisaduhin, mas may-retain itong mga to. Mga index card, diba? Ayan. Dahil nga di sa Prime is, hindi lang ako naging engineer, naging top 4 pa ako, top notcher, diba? So, yun, napalaking tulong talaga ng Prime Review Center na ito, kahit na pandemic. Thank you ulit sa Prime, and napalaking tulong nyo, and sana mas madami pa yung matulungan na magiging soon-to-be engineers, and thank you sa pakikinig, and ingat kayo lahat.
Magandang araw po sa ating lahat. Ako po si Engineer Emmanuel Villasin. Unang-una po, gusto pong pasalamat sa Prime Review Center sa pagbibigay po ng tulong at suporta sa ating mga future mechanical engineers. Para po sa mga mag-review pa lamang at mag-take pa lang po ng board exams, ang masasabi ko lang po is review smarter, not harder. Kailangan po muna nating alamin yung mga weaknesses natin bago po tayo mag-focus sa other topics. At since online review nga po ito, kailangan po natin magkaroon ng disiplina dahil wala po nagbabantay sa atin sa bahay. At kailangan po natin maglaan ng enough time to review. Sabihin na natin around 2 to 3 hours a day na pagsusolve po ng dire-diretso. Hiwalay po yun dun sa assessment na binibigay po ng Prime. At huwag na huwag po tayo magpapanik dahil kapag nagpanik po tayo, meron pong chance na baka makalimutan po natin lahat ng mga na-memorize na natin. And lastly, huwag po natin kalimutang magdasal at humingi ng guidance. Yun lamang po. Good luck sa ating lahat and God bless po.
Ayan. So, hello po sa inyong lahat, sa mga future engineers out there. Ayan. So, today gusto ko lang kayong i-inspire, i-encourage, at magbigay na rin ng ibang tips na nagamit ko sa pagre-review. And so, siguro marami sa atin dyan naninibago at nag-a-adjust pa sa online setup ng review. Pero okay mag-alala kasi it really works, guys. Yung program ng Prime, kita naman sa amin, mismong byproduct kami ng program na yan. And so, tsagain lang natin, talagang sundan din natin yung mga advice ng mga lecturers natin. So, yun yung unang tip. Sundin natin yung mga advice nila, like pagsulat sa index card, repetition ng formulas, and also mnemonics. Sobrang mahalaga na. Laking tulong sa akin yan. Promise. And also, tsagain natin yung mga 100 problems every day. May mga problems talaga na hindi natin alam i-solve, pero huwag kang madi-discourage kasi the next day, may solution naman. Aralin na lang natin yun. And then, lalong-lalo yung mga assessments, guys, tsagain natin yan. Tsinaga ko talagang pinush ko na aralin lahat ng hindi ko alam i-solve. Sinulat-sulat ko lahat yan, inulit-ulit ko, and eventually, ayan, it really helped me a lot. Nakapasa naman tayo and nakaabot pa sa top 10. Ayan. So, talagang diskartehan lang natin yan, tsagain. And also, pinakamahalaga is araw-araw na manalangin, humingi ng tulong kay God. And bibigyan niya naman tayo ng strength and ng wisdom. Basta humingi lang tayo sa Kanya. Ayan. So, hopefully, na-inspire kayo doon and sana makatulong. Sabi nga nung isang great philosopher, pag may goal ka, focus, success. Ayan. So, God bless po sa inyong lahat.
Good day everyone. I am Engineer Dinglasan. Recently, nag-top 9 sa Mechanical Engineering Licensure Exam last August 2021. First of all, let us thank the Lord for this opportunity na binigay niya sa atin na makapag-review at makapagbigay ako sa inyo ng konting advices lang sa inyong mga review classes. So, kung kayo ay napapagod, natatakot, nangangamba, kung worth it ba ito through the end, syempre yes, magiging engineer ka sa dulo eh. Masaya kaya maging engineer. Tapos, yun nga, every hardship ay merong kapalit na maganda sa dulo. Gusto ko lang kayo iwanan ng konting Bible verse from Philippians chapter 4 verses 13. I can do all things through Christ who strengthens me. So, kung ikay nangangamba, napapagod niya, napapagod, tinatamad, nandiyan lagi si Lord para gabayan tayo. Ako, talagang huminga ako ng kay Lord, ng encouragement, talagang huminga ako kay Lord ng dasal ako ng dasal sa throughout review, through the board exam, kahit yung board exam itself. After the board exam, talaga nagpapasalamat ako kay Lord na ginabayan niya ako talaga. Kaya yun, kailangan nyo lang talaga ng seek guidance through the Lord. Huwag matatakot. Good luck and God bless. Stay safe po sa atin. Thank you very much.
Passing the board is one of the greatest achievements that an average person like me can achieve. Topping it is a dream that only few gets to achieve. I myself never thought I'd be in this position, yet here I am. With passion to engineering, I get to boost my morale despite all negativities. With hard work and perseverance, I get to challenge myself and know my weakness and capabilities. With prayer, I get to know myself and what kind of engineer would I become. Magiging mechanical engineer ako. Claim it and receive it by faith. This what kept me going through the journey of becoming the top 10 of the August 2021 Mechanical Board Exam. At basta, magtitiwala ka lang sa mga turo ni Prime.
ng tatay ko, natulungan mo yung higit na nangangailangan. 20 years din ako sa abroad, pero umuwi din ako para sa pamilya ko. Mahirap magtrabaho abroad dahil mapalayo ka sa mga mahal mo sa buhay. Kaya I retired early to take care of them. Nung pandemic, nakita ko yung mga senior sa amin na nangailangan ng tulong. Naalala ko na naman yung tatay ko. Para ready akong tumulong lagi, may emergency pouch ako, may biogesic para sa sakit ng ulo, at may Immune Pro at 40D para sa vitamins at supplements. Ay subok na subok sa tagal na nitong ginagamit ng pamilya ko. Binabaon ko pa nga yan nung nasa Saudi ako kasi yan ang hiyang sa akin. Kahit ngayon, trusted ko pa rin ito para sa pamilya ko at para sa mga seniors na pamilya ko na rin. Para sa akin, ang alagang UNILAB ay alagang di ka bibitawan at di ka pababayaan.
Alagang UNILAB yan.
Hanggang malakas pa.
Hirap pang madilim. Kaya kung makakatulong tayo magbigay ng liwanag, bakit hindi? Nung nabalik po namin ang kuryente sa Leyte, nagkailaw lahat pagkatapos ng malakas na bagyo. Sobrang saya ko. Mahirap ang ganitong trabaho. Dapat alaga ka sa katawan mo. Kaya lagi akong may bawang Enerbon para may tulong pampalakas. Pag nagkasakit naman, BioFlow sa trangkaso. At pag may ubo, Solmux. Yan ang inaabot ni nanay lagi. Siya kasi ang nag-aalaga sa akin. Sa kanya ko rin nalaman yung mga gamot ng UNILAB. Sabi niya, maaasahan yun. Iba talaga yung sayang dala ng trabaho namin. Kaya naman, importante sa akin ang aking kalusugan para mas makapagtrabaho pa, para maraming matulungan at mapasaya. Para sa akin, ang alagang UNILAB ay alagang may mabibigay ka sa iba. Alagang nagbibigay ng liwanag at saya sa mga tao.
Alagang UNILAB yan.
Kapag atleta ka, team effort talaga yan. Dahil pag may kasama ako, kampante ako. Para manalo, kailangan ko ng tulong ng iba. Bukod sa sumusuporta, meron din nag-aalaga, katulad ng UNILAB. Kahit wala pa akong gold medal, pinagkatiwalaan nila ako. Sa sakit ng katawan, nag-aalaksan po ako. Kung may sipon, Newsep agad. Pag nangangasim ng sipmura, Creamil-S ang gamit ko. Hindi madali ang training namin eh. Nagda-doubt ako sa buhat ko, nagda-doubt ako sa sarili ko. Pero kailangan talaga may dream ka. Ang alagang UNILAB. Kasama ko. Ngayon nga, nagka-gold na ako. Nagpatayo ako ng gym sa Zamboanga. Nagbigay kami ng oportunidad na makapag-train sila together with me. Lahat ng experience ko as an athlete, kailangan kong ibahagi sa kanila. Feeling ko kasi, kailangan kong i-share ang alagang nakuha ko.
Alagang UNILAB yan.
Ayan, isang napakagandang gabi sa inyong lahat at isang very special evening to a very special person, Ram. Kilala mo ba kung sino ang may birthday na sineselebrate today? Of course, of course. And on behalf of PSME-UPSU K-pop stands, we'd all like to wish Nayeon a very happy birthday. And as they say in Korean, 𝐂𝐑𝐀𝐍𝐿. I really hope I pronounced that one right. We're already banned in France, so like I don't want to add Korea to that list. All right. Anyways. Yes. Happy birthday indeed. At ika nga ng twice, you make me feel special. Pero most importantly, alam mo ba kung ano ang perfect gift to your very special someone? Syempre, none other than your very own shirt from our Peace Merch. Kaya naman, check out the comment section or the caption to order your very own Peace Merch shirt. Now, are you guys excited to learn about what our speaker has in store for you guys today? We're also so excited to learn more and more about what our speaker has to offer. But before that, let us once again introduce ourselves. I am your host, Ram. And I'm your host, Gab. And together we are welcoming everyone to the National Mechanical Engineering Students Convergence 2022 Crank Up Seeing New Perspectives Day 4. This is brought to you by the Philippine Society of Mechanical Engineers, University of the Philippines Student Unit, in celebration of PSME Month 2022. Engage, rethinking today, reshaping tomorrow. Yes, now cheer up everyone for our fourth speaker, who is a licensed mechanical engineer who recently graduated as a cum laude from BS Mechanical Engineering in UP Diliman. He also received a Vicente Tech Hedriana All-Around Mechanical Engineering Award, which is given only to one ME student every year and is awarded based on academic grades, researches, projects, and community engagement. Now, our speaker ain't a scientist, but he is currently a design engineer in Yamaichi Special Steel Company Limited, where he does mechanical and thermal FEM simulations, topology optimization, and CFD simulations using FEM Solver. Here to talk about design optimization techniques, everyone send in some heart reacts for Engineer Kim Wesley Bautista. Once Engineer Bautista finishes talk, we'll have a short break before proceeding to Q&A. So without further ado, everyone send in some heart reacts and let's go.
Okay, so magandang gabi sa inyong lahat. So I am Wesley. So our topic for today is design optimization techniques. So for our presentation outline, so pag-usapan natin, so what we do at Yamaichi, what is AM, what is additive manufacturing, what are the current industry applications and our past projects, and then why is AM different, why is it revolutionary, and then next would be some design considerations, and then what is DFAM, and then the focus of my talk, which is design optimization, and then after that, our workflow overview, and then design optimization samples. Then, if we still have time, hopefully makapag-software demo saglit. So, just a little background about me. So, I was an exchange student 3 years ago in Hokkaido University. Then I graduated last year. And then this year, February, I took my licensure exam. And then I started working here last March. So in terms of experience, my experience isn't that much compared to other speakers, but I hope you will still learn at the end of this talk. So next is here, we are Yamaichi United Group. So established siya 1927, and then our main business is we sell strip wire bar materials, and then we do mold and tool materials. So we also offer machining and heat treatment, but I'm only focused on the additive manufacturing side of the business. And then our client is mostly from the automotive industry, but we also have clients from construction, medical device, aerospace, and semiconductor industry. So ito yung AM products workflow. So we sell and create filaments for 3D printing. We also create liquid silicon rubber. We also scan and optimize. So scanning for reverse engineering. we do 3D modeling, we do optimization, and then simulation. So we also print polymer and silicon rubber. And then for finishing and inspection, we do machining, annealing, painting, and laser painting, and measurement and inspection. So konting definition lang sa additive manufacturing because napag-usapan naman to nung first speaker on Monday. So AM is the construction of an object by depositing material layer upon layer in precise geometric shapes. So it uses data CAD software or 3D object scanners to direct hardware to add material. So here makikita mo dito sa GIF na to, makikita nyo kung paano layer upon layer nag-a-add ng material to form an object. So next, current industry applications naman, so may misconception na pagka 3D printing or additive manufacturing for for rapid prototyping lang. So siguro before ganun, pero ngayon gamit na siya ng iba't ibang industries. So for example, in this orthopedic cast, so pwede ka ngayon mag-print ng orthopedic cast. So bakit gusto mo ng ganitong klaseng cast? Kasi ito compared sa cemented ones, mas magaan to. And then mas may airflow din. And then washable din siya as compared to sa cemented ones. And then pwede ka rin mag 3D print ngayon ng hip cups. And then ngayon ginagamit na rin siya for osseointegrative implants. So ano ba tong osseointegrative implants na to? So makikita nyo dito yung porosity niya medyo kakaiba. So ayan kasi minimimic niya yung density ng bones natin. So bakit nga ba mahalaga na medyo minimimic ng implant natin yung porosity ng bones natin? Kasi gusto natin pag nag-implant tayo, as less intrusive as possible. So ang nangyayari kasi sa implant, ini-implant yan and then mag-grow yung bones around it. So pagka mas porous, mas madaling makapag-grow yung bones around it. So for automotive and aerospace naman, meron dito for example itong cold plate of an electric race car. So ito naman is lightweighted and at the same time mataas yung heat transfer than the traditionally made heat exchangers. So makikita nyo dito yung channels na to, may material pa siya na iba dyan. So yung reason nun is to increase the surface area. So alam naman natin, pag ini-increase natin yung surface area, lumalaki yung heat transfer natin. So ayan, and then meron na rin ngayon nag-3D print ng rockets. And then meron din dito isang project ng Renault. So papakita ko lang saglit. So may 3D print sila na part. For example, yung part na to, nung 3D print nila may 18% weight reduction. Ito naman 42% weight reduction. Ito naman 36 and then 36 ulit. And then nag-consolidate din sila ng part from 80 parts na integrate into one. And then dito rin from 45 na integrate into one. And then so ang weight reduced is 120 kilograms and number of parts reduced is 200. So for brake caliper naman, ito naman is 3D printed brake caliper. So makikita nyo dito kung paano nila tinetest yung 3D printed na brake caliper. So makikita nyo dito, subjected siya sa hindi lang sa high forces kundi sa high temperature load. So makikita nyo dito, very important na yung part natin dito is may magandang airflow. So compared to traditional brake caliper, mas nakakapag mas efficient, mas maganda yung pag-transfer ng heat dito. So next for construction naman, so may mga construction din mga companies din ngayon na nag-explore ng 3D printing, ng pag-3D print ng houses and then bridges. And then sa molding naman, so itong mold na to, so ngayon na-explore na rin yung pag-add ng cooling channels sa mga molds. So bakit ba gusto natin lagyan ng cooling channels yung mold? Kasi gusto natin na mas mataas yung heat transfer natin. Gusto natin sa mold kasi subjected yan sa very high temperature, like around 300 to 500 degrees, maglalagay ka ng molten metal dyan, and then i-cool mo to 80 degrees. So gusto natin mabilis yung process na yun para mas efficient, para yung mold natin makakabuo ng mas maraming parts per certain amount of time. So before, ang kaya nating gawing channels ay very basic na channels lang, like straight lines or simple cutting lang. Pero ngayon, dahil 3D printed na, pwede na tayong gumawa ng mga molds na mayroong conformal cooling like yung nasa right. So bakit natin gusto ng conformal na channels? Gusto natin kasi una, gusto natin nga mabilis yung pag-cool, at pangalawa, gusto natin na uniform yung cooling niyan. So bakit gusto natin ng uniform na cooling? Kasi ayaw natin na yung isang part lang yung nagko-cool ng mas mabilis, nag-i-induce yan ng stress. Ayaw natin yun. So ayan, makikita. So ito is a past preliminary study of mine. So makikita nyo dito yung simulations kung gaano ka-uniform yung cooling dito and gaano kabilis compared dito sa hindi gaanong conformal yung channels. So next naman, so dahil nga medyo mas madaling mag-manufacture using additive manufacturing, may mga artists din na yung artworks nila is 3D printed. For others naman, so ito naman is a past project ng company namin. So may part sa kanilang assembly line na yung assembly time very long, like for 18 hours. So in-approach nila yung company namin to reduce that assembly time. So ang ginawa namin is reduce the number of parts. So from 63 parts naging 7 parts na lang, and then yung assembly time na naging 18 hours naging 8 hours na lang. So next naman is itong speakers. So itong speakers na to, yung may mga ridges dyan sa likod, may mga wave pattern yan na dinesign in such a way na it can only absorb specific frequencies. And then next naman is itong shoes. So itong shoes naman, makikita nyo dito sa baba, made of lattices yan. So bakit natin gusto ng lattices bakit nila naisipang lagyan ng lattices yan? Kasi una, gusto natin lightweighted yung shoes natin. And then gusto rin natin bouncy. So to make it bouncy while na magaan pa rin siya, so nilagyan nila ng lattices yung baba. So next one, so why is AM different? So pwede niyo i-compare dito yung traditionally made versus AM parts. So ayan, pag i-observe niyo yung dalawa, makikita niyo dito na may mga similarities yung mga AM made. In fact, parang very obvious pagka yung isang part ay AM part. So ayan, so bakit ganun? So ang AM ay usually more complex yung geometry niya, and then yung traditionally made naman more usually mas simple yung mga shapes niyan. So bakit ganun? Kasi nga sa AM nag-a-add lang tayo ng material, hindi tayo limited sa tooling natin. So in short, AM gave us the design freedom. So if for example naglalaro kayo, so parang dahil sa additive manufacturing, meron tayong mga na-unlock na items dito na pwede na natin ngayon i-manufacture. So next naman, while AM gave us the design freedom, there are still some considerations na kailangan nating i-note when we are designing parts. So for example, itong printing angle, it should be lower than 45 para hindi mag-create ng supports, hindi kailanganin ng supports. So ito, ang gusto ko lang pakita dito sa part na to is there are still some considerations in designing a part. So of course, itong mga rules na to, yung mga considerations na to, not true to all printers kasi very rapid ngayon yung development ng 3D printers. So sa ibang printers, din mo na kailangan i-consider ito. So ngayon naman, what do you call yung designing process if you are taking into consideration the design freedom that that additive manufacture unlocks, and then yung mga considerations dito. So what do you call that design process? You call that design for additive manufacturing, or DFAM. So DFAM is designing with having in mind its printability. So this concept emerges due to the enormous design freedom provided by AM technologies. So to take full advantage of unique capabilities from AM processes, DFAM methods or tools are needed. So for us design engineers, before additive manufacturing, we only have few design choices. We are only limited to simple geometries, and we are heavily constrained. So for example, may pina-design sa atin, may kailangan tayong i-design. Usually naman hindi tayo binibigyan ng initial CAD. Usually, ang binibigay lang sa atin kung ano yung functional regions like these bolt holes, itong part na kung saan sinasabit yung load, and then yung stresses na hindi dapat nating lagpasan. So, at the start of designing, wala pa talaga tayo. Out kailangan natin mag-design ng isang part. So before, medyo hindi mo kailangan mag-isip ng mga complicated geometries because para saan pa? Kasi hindi naman natin kayang i-manufacture. But after additive manufacturing, ngayon kaya na natin mag-create ng complex geometries na way better in terms of performance sa part na magagawa lang natin noon. So in short, parang medyo nagka-problema tayong design engineers ngayon kasi dati konti lang naman yung mga designs na kino-consider natin. Ngayon medyo dumami na. Medyo kailangan na natin i-consider yung mga non-intuitive designs like this one. Like pag nagde-design ka naman, hindi mo naman may isip agad na ito pala ay mas optimal kaysa dito. So ngayon parang medyo tayo nagkaroon ng problema yung mga design engineers. So because of that, mas kailangan na ngayon yung skill of optimizing things because kailangan nga natin ngayon kaya na nga natin mag-produce ng mga complex geometries. So ito lang konting background on design optimization process. So mag-umpisa yan sa specifications, bibigyan ka ng specifications ng client mo, and then from that specifications maka-create ka ng initial design. And then pwede ka na rin mag-formulate ng optimization problem. So ano ba tong optimization problem na to? So for example, meron kang part na din i-design. Of course, yung kailangan mo i-consider doon yung stresses, dapat hindi lumagpas doon. Yung mga parameters na pwede mong paglaruan or yung mga shapes na pwede mong galaw-galawin. And then after that, you need to evaluate your objective and constraints. And then after that, you need to ask yourself kung na-achieve na ba yung optimum na design. So of course, if no, you need to update your design variables and then balik dito. And then if yes, you need to ask yourself again, is the design good? So bakit parang redundant to? Bakit meron na nga nito, tapos tatanungin mo pa, is the design good? Kasi minsan, pag nagpo-formulate tayo ng problem, pag nag-evaluate tayo ng objective and constraints, mayroon tayong mga bagay na hindi nako-consider. So here, pwedeng na-satisfy niya na lahat ng objective and constraints mo, pero meron kang ma-realize at the end of your design process na hindi pala maganda tong, may kulang pala. So pag ganun, you need to change the initial design or reformulate the problem and then back here, then go back here, and then if yes naman dito, meron ka ng final design. So next naman, so konting terminologies lang. So what is generative design? So it is a broad design methodology that allows engineers and designers to build both technical and non-technical requirements into their models. So medyo confusing kasi ngayon yung definition ng generative design, but for the sake of this discussion, let's stick with this definition. So there are many ways to do generative design, but we will only focus on these three ngayon. So pwede kang mag-add ng lattices and architected materials to your design. You can do topology optimization, and then you can do use fields to drive your design. Mamaya may mga samples yan. So next naman, so topology optimization. So it is a simulation-driven structural optimization tool. So designers define the technical requirements, and the software removes material from the designated design space through iterative simulation steps. So it does this by removing material that does not contribute to the overall strength. So ano bang ibig sabihin nun? So for example, meron kang initial design. So tingin lang muna dito. And then gusto mo i-topology optimize siya. So ano ba ang meaning nun? So pagka ito topology optimization mo siya, ang gagawin ng algorithm is search for every element that does not contribute to the stiffness of the design. So manually ng algorithm yan, i-check for example yung maliit na element dito. Pag tinanggal ba, bababa ba ng sobra yung stiffness niya? So if hindi naman, edi i-remove na yun ng algorithm mo. Then iterative process siya, paulit-ulit niyang gagawin yun to every element, and then uulit-ulit yun to hanggang ma-approach niya yung objective mo and your constraints. Ayan. So basically, it is like a toy problem. So ito ay parang ganito. So you have a problem. Ang problem is to design the stiffest shape by placing 60 Lego blocks into a grid of 20 by 10. So may cantilever beam ka dito, for example. And meron ka lang limited material, 60 Lego blocks lang to design the best cantilever beam. So pag gusto nating manual ito, kasi ang hirap naman alamin agad kung ano nga ba yung optimum design. Pag gusto nating manual process and you want to calculate the stresses and the strains in every design combinations, ang kailangan mo lang naman computein is 200 C60, which is 7.04 times 10 raised to 51 na stresses, na strains, na kung ano man yung parameter na chine-check mo. So, very hassle siya pagka manually mo siyang ginagawa. That's why meron na tayo ngayong mga software na nag-automate ng pag-calculate ng mga stresses and all. And then, para ma-achieve yung optimum design katulad niyan. So, makikita rin dito sa GIF na to kung paano siya nag-start and then onti-onting nag-approach siya sa optimum na configuration. So, next naman is lattices. So, what are lattices? So, lattice structures are repeated patterns that fill a volume or conform to a surface. So, in engineering design, lattices are cellular materials that are often inspired by nature that consist of beams, surfaces, or plates that fit together following an ordered stochastic patterns. So, meron tayong iba't ibang klaseng lattice types. So, hindi ito exhaustively. Sobrang daming klase ng lattice types. May beams, may honeycombs, may stochastic, may TPMS. So may kanya-kanyang property yan. Like itong honeycomb, mataas yung directional stiffness niya. Itong TPMS, maganda siya kasi na-maximize niya yung surface area mo at the same time stiff din siya. And then pag ipiprint mo yan, wala kang maproproduce na any support. So ito namang lattices na to ay hindi siya bagong concept or hindi siya bagong discover. In fact, nagagamit na siya natin before pa. So for example, sa mga bridges and for example, sa mga dito sa Eiffel Tower, makikita mo na hindi naman yan solid material, kundi consist yan of beams. So ayan, lattices din yung tawag dyan. Sa airplanes naman, makikita mo yung wing ng airplane hindi yan solid. So yan ay hollow lang yan and then consists of lattices. So bakit natin gusto mag-add ng lattices? Kasi of course gusto natin na lightweighted yung material and at the same time nakakapag-save tayo ng material. So ayan. So here is our design optimization workflow in our company. So pagka may client kami, usually kung nag-optimize lang sila, mag-start kami sa CAD na provided nila. And then minsan naman kailangan namin gawin from scratch. So for example, may CAD na kami and then after that we need to optimize it using the concept that I discussed a while ago. So mag-design optimization kami. So from this part, ila-lightweight namin yan or anumang requirement, anumang specifications gusto ng client, magiging ganito siya. And then we will do some DOE and generate multiple design variations using Optibot. So anong meaning nun? So pag nag-optimize ka kasi, hindi mo naman sure kung optimize na ba talaga yan. Kasi marami kang parameters na nagka-come into play, marami kang parameters na pwedeng i-tweak. For example, itong beam na to. Paano tayo naging sure na yan pala yung optimum placement niyan? Paano kung dito siya nakalagay? Paano kung dito? Paano kung mas thick siya or mas mapayat? Mas gaganda ba yung performance niya? So yung mga ganung bagay, very hard na para i-compute natin by hand or i-simulate. So para makita talaga natin yung optimum, pwede tayong gumamit pwede tayong mag-generate ng multiple design variations. So in our case, gumagamit kami ng Optibot to automate this process kasi medyo repetitive siya. So ayan, mag-generate ng multiple variations. Then pagdating dito may problem ka na ulit. Kasi ngayon, ang dami mo ng parts. Paano mo ngayon pipiliin yung optimum design? So for that, konting statistics lang, konting kung kayang i-plot. Of course, pag nag-Optibot ka, kasi pag nag-generate ka ng multiple design variations, of course, pwede mo nang ipunta agad sa isang simulation software and then extract mo yung mga stress values or any other parameters na mahalaga sa'yo. So in case dito, for example, ito yung parts mo, pwede nating i-plot sa isang 3D diagram. For example, ito yung max stress mo. For example, ito yung printing time. So pag naghahanap ka ng design na mababa yung max stress and at the same time mababa yung printing time, edi hahanap ka ng parts na nandito sa area na to. So ayun siya. And then after that, you need to do a final validation. So ano ba to? I-simulate mo lang ulit sa software kung pasok nga ba sa design requirements mo yung na-generate mo na design. And then of course, di pa tayo satisfied doon kasi lahat ito ay sa software lang. So of course, sa dulo, kailangan din natin mag-reality check wherein actual na natin itetest yung ating designs. And then ito naman, hindi siya step-by-step process. Pwedeng along the way, may ma-realize ka na may mali. Pwede kang bumalik sa start. Ayan. So, para lang mas makita nyo ng mas maigi. So, ito, for example, nag-start ka sa ganitong part, i-optimize mo siya. In this case, ni lightweight namin, magiging ganitong part. So, using the concepts na sinabi ko kanina, magiging ganito siya. And then, using Optibot, it will automatically generate these parts. So, ayan lang, some animation lang. Ayan, mag-generate siya ng multiple parts. And then after that, isi-simulate mo siya. And then, since nakuha mo na yung parameters na mahalaga sa'yo, you can plot it. And then from here, makakapili ka na kung saan ba yung design na nag-satisfy ng iyong requirement. So in this case, gusto mo ng maliit yung part volume, maliit yung printing time, maliit yung max stress. So focus ka sa mga designs na makikita mo dito. And then ito na yung final design. And then now you have to do the final validation and reality check. So next naman, some samples lang. So ito naman ang gusto natin is to lightweight the design using topology optimization. So for example, may client ka and ang request niya, gusto niya ng robot arm mas mabilis. So ano lang yon, dalawang way lang yon para magawa yon. One is to either lakasan mo yung power input mo, of course. Pag nilakasan mo yung power input mo, bibilis talaga yan. Or two, pwede mong i-lightweight tong material na to. So for example, ito lang yung pwede nating i-optimize na part. So ito ay sa n-top. For example, ayan. So of course, kailangan mo munang i-mesh yung part mo, and then you need to declare your boundary conditions, kung ano ba yung forces mo, saan ba siya constrained. So ayan, and then after that meron ka ng results. So of course magra-run in a while yung software mo, and then after that magkakaroon ka na ng results na ganito, most likely magiging ganito yung itsura. Makikita mo na maraming material yung ni-remove automatically. So ayan. Makikita nyo kung gaano na-reduce yung volume nung part natin. And then, of course, in every optimization naman na technique, kailangan mong i-post-process yan. So, sa case na to, ma-observe nyo na very rough yung part. So, kailangan nating i-smoothen yan para less yung mga stress concentrators natin. Ayan. So, ayan na siya. And then, itong part na to, originally, 54 kilograms siya. Then, after optimization, I think naging around 22 kilograms na lang siya. Ayan. And then, of course, meron kang result, pero hindi mo sure kung pasok ba sa design requirements mo. So, after that, you need to do some simulations. Ayan. Check lang yung deformation, check yung stresses. And then, after that, ready for export na siya, or pwede na rin i-3D print kung hindi ka na magpa-final validation and testing. So next naman is, ito naman, ang gusto kong pakita dito is the concept of using fields to drive your designs. So for example, meron kang isang bike seat. Gusto mo ulit i-lightweight. And then, ang initial na gagawin is to do simulations kung ano nga ba yung mga stresses mo, para alam mo kung saan yung part na pwedeng bawasan or pwedeng modify. So here, ito yung results mo. So dito, kitang-kita kung saan concentrated yung stresses. I'm not sure if this is stresses or strains. So ito yung results mo. And then, you want to use that to drive your design. So So in this software, madali lang siyang gawin. Pwede mo siyang parang i-code na, for example, if your stress is this high, ganito yung corresponding na gagawin mo. If your stress is low, ganito yung corresponding na mangyayari. So sa case na to, nilagyan niya ng lattices yung bike seat. So dito parang yung code natin, if high stresses, high density yung lattices mo. If low yung stresses mo, low density yung stresses mo. So bakit ganun? Of course, pag high stress, mas kailangan natin ng material doon na magsusupport. So ayan yung itsura niya. Yan, kitang-kita dito na yung high stresses, mas maraming material compared to dito na low stresses. So ayan. And then you need to post-process it para mas maayos. So ito na yung final part mo. Ayan. So next naman, so pwede mo rin siyang gamitin if for example you want to make a custom-made na shoes. So for example, meron kang pressure map ng paa mo and then gusto mo na comfortable yung shoes mo, magaan, and at the same time nagko-conform sa shape ng paa mo yung shoes mo. Pwede kang kumuha ng pressure map ng paa mo and then you add some lattices. So dito naman pag high yung pressure, high yung density. Pag low yung pressure, low yung density. So ito. So hindi mo kailangan ng very expensive na material para kumuha ng pressure map, no? Minsan pwedeng picture lang. For example, apakan mo yung clay, tapos picturean mo, tapos i-post process mo 'yon kasi makikita mo naman yung mga deformation sa clay. Pwede mong i-post process 'yan, image process lang. And then may gagamit mo na siya to drive your designs. So of course, pagka for example, kayo may experience sa CAD, ang first na question niyo dito, ang hirap naman mag-design ng ganito, ng lattices. Kasi for example, sa traditional CAD, ang gagawin mo isa-isang beams yung lalagay mo. So sobrang hassle and time consuming naman yun. Pero sa mga modern CAD software ngayon, hindi mo na kailangan gawin yun. Automatic lang siya, para ka lang nagko-code talaga na if your stress is high nga, if your pressure is high, tataas yung density or for example, ititiken yung part na to. So, ayun. So, next naman, ito naman is using yung tatlong concepts. So, lightweighting using topology optimization, using fields, and using lattices. So, for example, ito ay isang rotating device. So, pinapa-lightweight ng client, for example. So, for example, dito may step model ka. I-mesh mo lang and then you will do some topology optimization. This is automatic and then you will do some post-processing, smoothen mo siya, and then you will do some simulations. So i-check mo ulit sa software mo kung saan nga ba stressed. So ayun, pagka meron ka ng results na ganito, pwede mo again ma-extract yung values and then yung areas of high stresses mo, pwede mong lagyan ng lattices na thick as compared sa areas na low stresses. So ayan, and then post-process and then you can export it and then print it. So just to show you more clearly, high stresses nag-correspond sa highly dense na lattices, low stresses nag-correspond sa porous na lattice. So ayan. So kung gusto mo example na mas optimize pa yung object mo, after mong gawin to, pwede ka ulit mag-simulate. And then, itikan ulit yung mga parts na may high stress. And then, ito naman, flow optimization. So, for example, ang pinapa-design sa'yo, may original part ka na, ito ay isang pipe, for example. Dito yung inlet, and then dito yung outlet. So, dahil L-bend to, dahil alam natin from our fluid class na pag may L-bend tayo, sure na may losses yan, sure na may corresponding pressure drop yan. So, gusto natin ngayon i-minimize yung losses. Gusto natin i-minimize yung mga vortices dito. So, to do that, we have to, of course, simulate first. Check kung saan yung areas ito yung mga areas na mababa yung velocity, meaning maraming losses dyan. Ito naman red area naman yung high velocity. Then convert that to a point map and then use that point map to drive again your result. So dito ang parang code mo, if your velocity is low, then add material. If your velocity is high, then remove material. So ito, using the simulation results, automatic mo ma-generate itong part na to. But of course, hindi pa yan optimum na design. Kung gusto mo nga na mas maganda, you can repeat this process. You can do CFD optimization, CFD simulation again, extract those point maps, and then you can use those results again to drive your design. And then ito naman for thermal management. For example, may fins na pinapadesign sa atin. So ayan. So for example, mainit sa baba and then fin to. Gusto natin ng mataas na surface area. Gusto natin na mataas yung heat transfer. So ngayon meron tayong may mga pagpipilian tayong designs. But just by looking at it, hindi natin alam kung ano yung best results dyan. So sa thermal management, medyo mahirap gamitin lang yung intuition para malaman yung best design. So here, ang kailangan natin i-generate natin isa-isa. So parang trial and error siya, pero automated na ng software. And then i-extract yung results one by one. And then get kung ano yung pinakamataas na heat transfer. And then dito naman, workflow optimization. So here, kanina, ang ina-optimize natin yung design. Dito naman, ang i-optimize natin yung way of designing. So may konting demo lang. So for example, meron tayong nasa setting tayo sa hospital, for example. And then meron tayong pasyente na kailangan ng prosthetics, kailangan ng ganito. So ngayon, kailangan natin mag-design ng prosthetics. So may konting process lang, pero hindi naman yung process, yung mga details yung mahalaga dito. Pero ayan lang, para lang mapakita yung process. And then i-declare mo lang yung portion mo na lalagyan ng prosthetics because hindi naman yung buong kamay yung nilalagyan ng prosthetics. Ayan, dineclare mo lang dyan. And then you will trim it. Ayan na yung prosthetics mo. Okay, thank you. Ayusin ko lang. Wait lang. Ayan, thank you. Ayan, kita na. Ayan, sorry. Okay, so ulit tayo. So, for example, meron kang scanned copy ng iyong arm. Nasa hospital setting tayo. And then you want to make a prosthetics like this one. Of course, ang prosthetics dapat nagko-conform to the shape of the arm. So, ayan, ipaprocess lang konti. Hindi naman masyadong mahalaga yung process dito, but just to give you an idea. Ito siya. Then, declare mo yung part na mahalaga, yung lalagyan mo ng prosthetics. And then, do some processing. You trim it. Ayan. And then, of course, gusto natin ng prosthetics na magaan at the same time maganda yung airflow. So, we need to put a lattice there. So, ayan, lattice. So, dito naman, yung parang code ng lattice mo, yung parang program ng lattice mo, if yung lattices mo are near the edges, mas dense siya. So, bakit ganun? Kasi naman, sa edges naman talaga yung stresses ng ating prosthetics. And then, do some post-processing. Ayan, add something. And then, here's your final brace. But of course, nakikita nyo ba how inconvenient itong process na to for a doctor? For example, may bago siyang pasyente. Napaka-hassle naman kasi magre-redesign na naman siya. Parang no doctor can do that, na magre-redesign every time na meron siyang bagong pasyente. So dito, in-introduce ko yung concept of reusable workflows. Here at NTAP, not just in NTAP, pwede mo rin siyang i-automate in other software. Pag may binago kang parameter sa taas, automatic magra-run yung code mo. Automatic magra-run itong mga steps na ginawa mo na previously. So for example, meron tayong bagong pasyente. Meron tayong bagong kamay. Ito yung previous arm natin. Ito yung bago nating kamay from our new patient. So here, very easy lang, no, para makagawa ng bagong prosthetics. I-declare mo lang yung arm mo na nilagyan na dinidesign. I-declare mo lang yung part, yung mga portion na lalagyan ng prosthetics. So in this case, ang lalagyan mo ng prosthetics ay itong part. Itong part lang. So, dito maghihintay ka lang for a while kasi magre-run yung program. So, wait natin, mga 30 seconds din to eh. So, kanina kasi preloaded yon. So, nakita nyo agad yung results. Dito, nagme-mesh pa siya. May ginagawa pang manipulation sa CAD. And then, wait lang natin. So, by the way, this is topology. So, yung ibang siguro may experience na sa CAD, bakit medyo mabilis dito? Kasi topology uses implicit modeling rather than BREP. Pag ikaw, so ano ba yung implicit modeling? So para ma-represent to, for example, itong CAD na to, so yung mga traditional CAD, ang ginagawa, ini-store niya every vertex, every edges ng design. Here, hindi ganun yung process ng software. Ang ginagawa niya, ini-store niya equations that represent this CAD. And then, ayun, tapos na siya. Ito na yung bago nating arm. So, nasan na yung original? So, without doing anything, nag-drag lang tayo ng ilang parts, meron na tayo ngayong redesigned arm. So, ito yung concept of optimizing the way you design things. So ayun. For example, hindi lang sa kamay yung kailangan ng prosthetics. For example, ang paa naman, sa leg naman. Ganun lang din ulit yung process mo. Just drag this down and then declare the portion na kailangan mo ng prosthetics. And then wait lang ulit tayo ng around 30 seconds. Ayan. So very important to no sa mga bagay na custom made. Like for example, sa mga helmets, kung gusto mo ng very very saktong design sa mukha mo yung helmet, pwede kang gumamit ng ganito. So, ayun. Marami siyang pwedeng applications. Hintay lang tayo na magre-run yung entire program. So, ayan. So, ngayon, ganito pa lang itsura niya. Pero onti-onti yan nagbi-build ng prosthetics. Wait natin. And then, ayan, kita nyo nagra-run one by one yung blocks natin. And then, meron na tayong bagong prosthetics sa ating paa. So, ayun lang. So, ito lang, sana nagkuha nyo yung concept of reusable workflow. So, ayan. So, next naman. Wait lang, may isa pa akong demo. So, ito naman, demo lang ulit ng topology optimization. So, ayan. Kita nyo naman na. Okay. So, for example, meron tayong brake pedal na gustong i-redesign. Ang gusto ulit natin dito, i-lighten yung body. Kasi, for example, for race car siya. So, very important ang weight. Very important na ma-reduce yan. So, dito, i-declare mo lang yung mga parts mo. Like, ano ba yung pwedeng i-optimize. Sa case na to, ang sinabi lang ng client na pwedeng i-optimize. For example, itong loob na to. So, i-declare mo lang onte, turn it into a mesh, and then do some simulations. Ayan, simulations. Of course, bago ka makapag-simulate, kailangan ilagay yung mga forces and parts kung saan siya fix. So, ito na yung simulation results mo. Makikita mo kung paano siya nag-deform. Ito yung nakikita, pwede mo OA yan yung deformation. Pwede mong check yung stresses. So, ayan, kita mo yung parts kung saan highly stressed. So, itong mga yellow-orange part, highly stressed yan. So, parang meron na tayong idea kung ano yung pwede nating i-modify na part para less yung stress. Then, do some topology optimization. So, topology optimization is like setting up your simulation. Lalagay mo lang ulit yung stresses mo and all. And then, meron tayong results. Pwede nating i-tweak kung ano nga ba yung gusto nating, gaano kalala yung pag-remove na ng material. Makikita rin natin dito yung iterations. So, ayan, nagta-transform yan to achieve the optimum design. And then, we can do some post-processing. Ayan, post-processing. And then, wait. So, ito na yung final body natin. But of course, minsan hindi tayo satisfied sa result ng topology optimization. Minsan gusto natin mas manual. So for that, we would use lattices naman. So, for example, may lattice tayo here. Maglalagay tayo ng lattice. For example, itong lattices. And then, mayroon tayong simulation results kanina, di ba? So, meron tayo niyan. So, alam natin yung areas of high stresses. Then, dito naman yung, kukunin natin yung values na niyan para alam natin kung saan yung part na pwede nating itiken. So, ayan. So, ayan yung thickened part. So, makikita nyo na thickened kung saan yung highly stressed. And then, of course, hindi tayo pwedeng mag-stop lang dyan. Kailangan ulit natin mag-simulate and check again the stresses. Ito yung displacement. Ito yung stresses. So, makikita nyo dito, lumipat na ngayon yung maximum stresses. From gilid, nasa gitna na. So, kung kailangan mo, for example, i-redesign pa ulit to para mas maganda pa ulit yung part mo, pwede mo ulit itong gamitin to know where, yung kung saan yung parts na i-edit mo ulit. So, ayun lang. Balik tayo sa presentation. Wait lang. So, ayan. Kita pa. Ayan. So, yun lang pala. So, here are my sources. Ayan. And then, thank you for listening. So, sana naman nakuha kayo sa talk ko. So, kahit medyo kabado ko. So, if you have future questions, you may reach me through my LinkedIn page. And then, I hope sana kahit paano nakuha nyo kung paano nag-advance na yung ating field. So, sana ma-excite kayo kasi parang before, sobrang pag may idea ka, very hard to make it to a reality. Like, paano ka gagawa ng mold. Ngayon, mag-3D print ka na lang. Tapos ngayon, pag mag-optimize tayo, hindi naman natin kayang i-manufacture. Pero ngayon, kaya na natin. And then we have some computers to do it. And then we also have some software na develop na to do it. So sana makita nyo on how lucky we are that we are living in this time wherein pa-develop pa lang tong mga technology na to and pwede tayong mag-ride dun sa development na yon. So, yun lang, very important yung mga naaral natin sa classroom na mga theories. So, ayun lang. So, thank you for listening and ayun, goodbye. Then may Q&A pa. Okay.
Okay. So thank you, Engineer Bautista, for that talk. And honestly, at first, I had like zero idea what that topic was about talaga. Pero I guess that brief TLDR is how much, I mean, from what I understood, like first impressions, like how much material can you remove before it becomes unsafe or something? What do you think, Gab?
Ako, initially, like, pumasok agad sa isip ko was like geography for some reason. Kaya hindi ko, kaya medyo nagulat ako dun sa topic. But, yun, naisip ko rin yun, nabanggit din natin kanina, like, siguro sa chat, gano'n. Nabanggit natin na it's interesting how yung topic for today is an incorporation ng mga topics for like the previous speakers. Meron tayong prosthetics, meron tayong 3D printing. So ayan, that's very, very interesting. And now we are sure that everyone has a lot of burning questions for Engineer Bautista. So make sure to use our Menti.
And once again, like always, you go to menti.com and type in the code 41150522 to ask your questions. But before we proceed, we'd like to once again thank our sponsors and partners. So see you in a bit. NMESC 2022 is presented to you by Philippine Society of Mechanical Engineers, University of the Philippines Student Unit.
Co-presented by Prime Mechanical Engineering Review Center, Zion Studios PH,
UNILAB Incorporated, Enervon Multivitamins, brought to you by Davies Paint Philippines Incorporated.
our media partners, SparkUp,
Our community partners, Bataan Peninsula State University Society of Mechanical Engineering Students, Junior Philippine Society of Mechanical Engineers, Cavite Chapter, Junior Philippine Society of Mechanical Engineers, De La Salle University, Dasmariñas, Junior Philippine Society of Mechanical Engineers, Don Mariano Marcos Memorial State University, Midlo Union Campus Student Unit, Junior Philippine Society of Mechanical Engineers, Emilio Aguinaldo College, Cavite, Junior Philippine Society of Mechanical Engineers, Maragondon Branch,
Junior Philippine Society of Mechanical Engineers, Polytechnic University of the Philippines, Alfonso Campus, Junior Philippine Society of Mechanical Engineers, USTP Chapter, Junior Philippine Society of Mechanical Engineers, Xavier University Chapter, Philippine Society of Mechanical Engineers, Technological Institute of the Philippines Student Unit, Manila, Philippine Society of Mechanical Engineers, Technological University of the Philippines Student Unit, Philippine Society of Mechanical Engineers, Camarines Norte State College Student Unit,
Philippine Society of Mechanical Engineers, 𝐂𝐭𝐲 de Muntinlupa Student Unit, Philippine Society of Mechanical Engineers, Bicol University Student Unit, Philippine Society of Mechanical Engineers, Lyceum of the Philippines University, Cavite Student Chapter, Philippine Society of Mechanical Engineers, National University Student Unit, Philippine Society of Mechanical Engineers, Pamantasan ng Lungsod ng Maynila Student Unit, Philippine Society of Mechanical Engineers, Pangasinan State University Student Unit,
Philippine Society of Mechanical Engineers, PUP Student Unit, Philippine Society of Mechanical Engineers, Sorsogon State University Student Unit, Sorsogon Chapter, Philippine Society of Mechanical Engineers, Tarlac State University Student Chapter, Philippine Society of Mechanical Engineers, University of Batangas Student Chapter, UP Geodetic Engineering Club, Philippine Society of Mechanical Engineers, Sorsogon State University Student Unit, Sorsogon Chapter. And a special thanks to UP Mining Metallurgical and Materials Engineering Association Incorporation.
Okay, and we're back. All right, so I think we can move on to our first question. And this one, wow, okay, these questions are already getting tough right away. So, have you ever tried using topology optimization on compliant mechanisms?
If personally na-try ko na, hindi pa kasi medyo mahirap isipin kung paano yung nangyayari sa compliant mechanisms eh. So compliant mechanisms kasi yun yung pag may deformation ka, useful yung deformation na yun sa isang task. So hindi pa, pero ine-explore namin siya ngayon, like sa mga robot arms kasi magandang. For example, meron kang object na ginagrab, gusto mo compliant siya in such a way na pagka may grab ka, hindi siya magka-crumple, kundi may enough force lang siya. Kahit lakasan mo yung force na yung motor mo na nag-grab nun, magde-deform siya in a such a way na hindi magka-crumple yung makukuha mo. So, ganun yung mga compliant mechanisms. Pero wala pa akong study about that.
Maybe in the future, sir.
One day,
Thank you,
one day.
sir. Yeah. Our next question is, how accessible are the softwares for student or hobbyists?
Oh, for yung Entomology and yung Fusion 360, free siya for students. I don't know the process kung paano mag-apply, pero nakalagay sa webpage nila na free for students yung Entomology. So habang students pa kayo, gamitin yun na siya.
Oh my. Pan.
Okay. So nung March lang ako nag-start, no? So medyo konti pa yung experience ko, pero dito kasi sa medyo parang ano ba? Medyo parang training pa lang ako eh. Pero of course compared sa Philippines kasi parang dito parang sabak agad sa pagde-design. So ano ba? Ano pang meron dito? Parang pare-parehas lang naman kasi yung design, yung pagbigay sa'yo ng requirements compared sa Philippines. So wala rin kasi akong experience sa Philippines. So after kong graduate, dito ako napunta. So I cannot compare talaga really kung ano yung difference working here and working there. Ayan.
Yeah. Okay. Thank you for that, sir. Our next question is, very relevant. Tinatanong nila, kailangan po ba maging magaling sa coding para sa topology optimization?
No, hindi siya parang coding na may type ka, no? Parang coding siya in such a way na meron kang blocks and then ilalagay mo lang yung blocks na yun tapos magsiset ka lang ng mga numbers, ng mga parameters and then iti-tweak mo lang yun. So hindi ka talaga nag-code in such a way na hello world, gano'n, mag-type ka ng mga hindi siya gano'n. Parang block siya.
Coding na parang pang beginners, di ba? Yung parang may
Yeah, you just drag and drop.
Yes.
Nakalimutan ko yung pangalan.
Drag and drop.
Yes.
Yeah, so you can just set the parameters, machine does the rest, and at least that's what I understood from the talk, sir.
But meron din naman, pwede mo rin i-code eh. Pero of course, para sa lahat, pwedeng drag and drop lang. If kailangan mo lang i-explore pa yung other features, pwede mo rin i-code.
Okay, so that's for if you want to go more in depth. Okay, sir, thank you for that. On to our next question, sir. Do you have to be a creative or artsy person to be a design engineer?
No. Paano ba? Parang as long as nasa-satisfy mo kasing design requirements, parang hindi naman. Kaya nga meron mga generative design and topology optimization kasi siya na yung nag-iisip sa'yo ng magiging structure niya. And then imo-modify mo na lang, ipopost. Ganito, i-declare mo kung anong type of manufacturing siya and then yung algorithm na yung bahala dun sa constraint na nilagay mo. So hindi lang siya for additive manufacturing. So ayun. So for hobbyists naman, of course, minsan tinatamad tayo mag-isip kung paano mag-form ng objects. So mag-topology optimization ka na lang, declare mo na lang yung mga forces mo and constraints and then automatic na siyang mabibuild.
Yeah. Okay, thank you, sir. On to the next question. Sir, how are these designs normally like tested or compared? Like, do you actually make them first, like one of each, and like physically test them, or like do you just simulate it and all good, or?
Actually, usually isa-simulate muna siya. Like gusto mo katulad sa yung pinakita ko about Optibot, mag-generate yun ng mga around 1,000 variations para sa isang part lang. So pag ipiprint mo yun, very costly. So isa-simulate mo siya, i-reduce mo as much as possible. Tapos pagka na-validate mo ulit, nag-simulate ka ulit, tapos pasok naman sa design requirements, pwede mo nang i-print yun and then do the actual testing. And then after that, of course, kung 5 parts pa yung natira, pwede mo nang i-compare using the simulation results and the actual results.
Yes, sir. For our next question, we have, how do I get started with CAD and topology optimization?
Okay, so sa akin, nag-start lang ako last year, I guess. kumuha lang ako ng courses on Coursera, like yung sa Fusion 360 na courses doon. So doon lang ako nag-start, and then YouTube, dahil meron namang mga free licenses. So katulad ng sa Entomology, free naman. Pero I suggest before starting with before using Entomology, punta muna kayo sa mga CAD modeling talaga, like Fusion 360, CATIA, ganun. So kaya siyang online lang.
I think na-answer na rin yung next question na.
Yeah. So I think, this is a pretty interesting one. I'm actually curious then. So, sir, are there any applications in large-scale manufacturing? Because we've seen all of these like devices or mechanisms that are optimized, and they seem very complex. So I find it hard. Like, I think it'd be hard to see like how it would work on a mass manufacturing scale, large scale.
So, correct yun, no? So, medyo konti nga yung application niya sa large manufacturing, sa mass production. Pero, may nakikita kaming mga industries na mix yung manufacturing. So, for example, sa molding, yung molding pang mass production yun, di ba? So, yung ibang parts ng molding, 3D printed para mabilis magawa and then cheaper than machining it. So ayun, may mga industries na mix additive manufacturing and traditional manufacturing.
Mixing both, yeah.
Yan. Naisip ko lang kanina yung sa Eiffel Tower, I think.
What?
Di ba isa yun sa mga examples kanina of that? Or maybe
what is it? No? Wait,
lattices lang ata or something like that.
I mean, I guess it is maybe like a very old way of doing
very
it.
traditional.
Back when ANSYS wasn't like a thing. I'm not sure when the Eiffel Tower was made. Dude, we're getting banned. We're getting banned in France again. We're gonna get banned in France again. Okay, we're getting sidetracked.
Yes. For our next question, we have: are there scenarios where you think we cannot apply topology optimization? Siguro aside dun sa large scale nga.
Okay, so pag nagto-topology optimization kasi, you need objectives, you need constraints. So the software dependent yan, no, kung ano yung kaya ng software mo. Kung yung iba kasing software kaya maglagay ng manufacturing constraints. So meaning, kunwari extruded yun, pwede niyang i-note yung na gantong direction pala siya extruded, therefore ganito yung design na pwede. Ganito lang yung design na pwede. So ayun, software dependent siya. And then yung topology optimization as of now, nakabase siya sa mga static loads lang. I don't know kung may topology optimization na kaya, for example, moving objects, yung mga highly yung mga moving objects na composed of a lot of parts. I don't know kung meron ng software na kaya nun. Pero may strategies on how to still use this current software para sa mga ganun eh. Pero right now, hindi very accurate yung results sa mga ganun, sa mga dynamic loads.
Okay, that's so we can't just use that for everything. Okay, I was under the impression you could just hack your way, pero all right, you learn something new every day. Thank you, sir. So on to our next question, sir. Do I need any special certification or training to be a design engineer?
No, actually, kahit hindi ka mechanical engineer, you can be a mechanical engineer here in Japan. So, hindi mo kailangan ng PRC license, kailangan mo lang ng degree. Minsan nga, may colleagues ako na mechanical engineer ang title, pero high school graduate. So, as long as you get the concept, as long as ma-prove mo yung using some portfolio na kung anong capable ka, pwede here.
Okay, so you hear that, guys? You don't actually need to take the boards to work abroad. So like you already know. I mean, I won't say much about the boards naman. Let's not go there. Pero the more important thing naman is you learn, right? There's a difference between being well trained and well educated.
Yes.
More 303 idiots rip off line. Anyways, I think we can move on to the next question.
For our next question, sir, what is the hardest thing that you have optimized?
Yung robot arm, hanggang ngayon hindi ko pa siya tapos. Inumpisahan ko siya 3 months ago, hanggang ngayon hindi ko pa siya tapos. So dahil nga dynamic yung loading nun. So yung pinakita ko kasi one scenario lang yun. May mga other load cases pa kasi na kailangan din i-consider. And then pag malaki na kasi yung part mo, di ba, minimesh mo siya para mag-simulate ka. So medyo mahirap na rin siyang i-mesh. Minsan yung meshing, nagte-take ng 3 weeks alone, yung meshing lang. So ayun, so for me, yung robot arm.
Is this yung longest nyo na rin, sir? Na like project as of the moment? Oh,
like, inumpisahan ko siya nung 1 month. 1 month na ako sa company. Hanggang ngayon, di ko pa siya tapos.
Oh my God. Oh my God, that's work. Maybe...
Like, I also have to read a lot of research papers kung paano ginagawa yon. And currently, for me, pag titignan mo lahat ng research papers, ang lahat lang nilang sinasabi, wala pang, yung theoretically accurate way to optimize the robot arm.
Very novel.
Well, I guess that makes sense. And I think that actually builds up to our next question, sir. So, sir, what are advances in topology optimization that you really look forward to seeing later on, like say 10 years from now?
So, ano ba? So, ngayon may mga constraints ka pa kasi na hindi pwedeng ilagay. Like, hindi lahat ng manufacturing constraints pwede mong ilagay. Meaning ng constraints yung, pagka nilagay mo kasing constraints, for example nga, for extrusion siya, medyo masusure ka na pwede yun i-extrude. Pwede siya i-manufacture using extrusion. Pag naglagay ka ng 3D printing na manufacturing constraints, ibig sabihin nun, yung mabibuild ng algorithm mo pwedeng i-3D print. Paano yung ibang manufacturing methods? So, hindi pa pwede yun sa ibang manufacturing methods. So, I hope after many years, magkaroon na ng iba pang constraints na pwedeng ilagay.
Yes, sir.
Thank you, sir. For our next question, did you always want to specialize in topology optimization?
No. I don't know kung paano ko napunta dito. Pero nung first ko nalaman yung additive manufacturing, medyo na-excite talaga ako kasi parang very novel sa akin siya. Kasi may mga ideas ako na, for example, may gusto akong gawin pero hindi ko naman siya magawa kasi wala akong means. And then nung na-introduce ako sa additive manufacturing, ayun, tapos gusto ko na mag-specialize sa AM and then sa AM pala, because of AM, mas madali din mag-topology optimization. So parang because of additive manufacturing talaga. Kaya nag-start din yung presentation ko sa additive manufacturing. Ayun.
Oh, okay. Oh, okay. So, sir, I think this next section is a bit interesting. So, do you think that there will be any opportunities in the Philippines for mechanical design engineers in this specific field, topology optimization?
I think yes. I mean, from the speaker nung first day, like nade-develop pa lang ngayon yung additive manufacturing, right? So ayun. So may mga companies na from his talk na nag-start ng mga 3D printing, and then bago pa kasi yung topology optimization nga, so hindi mo pa siya magagamit sa maraming bagay. So of course dadating din yung panahon na magagamit mo siya sa maraming bagay. So ayun. So pwede mo siyang gamitin sa mga paggawa ng heat exchangers, paggawa ng bridges, pwede mo siyang gamitin yung topology optimization doon.
Yeah. Thank you, sir. For our next question, we have, do you think that topology optimization should be incorporated in the BS curriculum?
I think hindi kasi very specialized ang topology optimization. Like ano lang siya, very specialized siya. Like pag-aaralin mo siguro yung theory on topology optimization and all. I'm not sure. Baka 1 month maaaral mo siya. So siguro ang pag magsasuggest ako ng curriculum is sa ano na lang, additive manufacturing na lang or optimization in general. So kasi very specific lang yung topology optimization. Marami namang ways to optimize, like adding lattices, using the fields, and others. Ayun.
Okay,
so it should be like more on the masters.
Yeah, I think it could work like as an elective, like 197, where you take the special ME fields.
Yes.
So one day, so sir, would you consider coming back to UP?
Of course. Of course. Hindi, of course, gusto ko rin not as a professor, but as a lecturer lang. No? Kasi Hindi ko alam kung kaya kong mag-produce ng papers every year. So, as a lecturer siguro. So, ayun. And then, I find it satisfying din na magturo. Like, may mga, sa mga org works noon, parang excited ako pagka nagtuturo eh. So, I hope mayroon akong credentials for that after ko dito.
One day, sir, we look forward to 197. Okay, so I think this is our last question, and I really look forward to this one. So, sir, how do you think the common Filipino citizen would benefit from topology optimization? Maybe like how would farmers benefit, or like just anyone in general? Because so far, I think the examples have been very specific, sir.
Mhm. So, yung topology optimization kasi very general siya, no? So, kung pwede mo siyang i-apply sa any machinery, hindi pwede mo siyang gamitin to optimize a machine para less yung fuel consumption, mas mura i-produce yung isang machinery for farming, for example. So, very broad. Pero, ayun, because you are optimizing something, of course, bababa yung cost mo, mas magiging accessible sa farmers yung mga machineries and all.
Hey, thank you for that, sir. And with that, I think that's all the time we have for Q&A. So I think all of us here had a wonderful time tonight. And once again, I would like to thank our speaker, Engineer Bautista, for giving a talk and for answering everyone's questions.
Yes, thank you, sir. And we hope that everyone learned a lot from Engineer Bautista's talk tonight. Syempre, again, sobrang related from our previous talk. So I hope na nakatulong din yon to understand all the things na diniscuss ni Sir kanina. And again, with that, we would like to call upon the NMESC 2022 co-head Paul, the hacker person Sim, to award our speaker with a certificate.
Philippine Society of Mechanical Engineers, University of the Philippines Student Unit awards the Certificate of Appreciation to Engineer Kim Wesley Bautista for sharing their knowledge and expertise on additive manufacturing, modern design optimization techniques during the NMESC 2022, given this 22nd of September 2022.
Wala naman. So, thank you.
Okay, and that ends day 4 NMESC 2022 Crank Up, or as I would like to call it, the PSME World Tour. So thank you again for attending, and we hope that everybody learned a lot from today's talk.
Yes, tama. World tour. From France, napunta tayo sa Korea.
Wait, Japan!
No, Japan! And as we always say, don't forget to answer our feedback form in order to be able to claim your certificates of participation for the event. The link is posted in the comment section and will be open for 1 hour only. So make sure to answer as soon as you can, and make sure that you also answer our raffle form, which should also be in the comment section to join the raffle event and get a chance to win an RK100 mechanical keyboard, Edifier X3S through wireless earbuds, or 500 pesos in cash.
And once again, I'd like to remind everyone that there is this merch once again. So please check the link out in the YouTube description or the caption of our Facebook. And thank you again for coming to NMESC 2022 Crank Up Day 4. And we hope to see you again tomorrow. This is your host, Ram.
And this is your host, Gab. And we wish you a very pleasant rest of the evening.
Thank you. See ya. NMESC 2022 is presented to you by Philippine Society of Mechanical Engineers, University of the Philippines Student Unit.
Co-presented by Prime Mechanical Engineering Review Center, Zion Studios PH,
UNILAB Incorporated, Enervon Multivitamins, brought to you by Davies Paint Philippines Incorporated,
our media partners, SparkUp,
our community partners, Bataan Peninsula State University Society of Mechanical Engineering Students, Junior Philippine Society of Mechanical Engineers, Cavite Chapter, Junior Philippine Society of Mechanical Engineers, De La Salle University, Dasmariñas, Junior Philippine Society of Mechanical Engineers, Don Mariano Marcos Memorial State University, Bidlo Union Campus Student Unit, Junior Philippine Society of Mechanical Engineers, Emilio Aguinaldo College, Cavite, Junior Philippine Society of Mechanical Engineers, Maragondon Branch,
Junior Philippine Society of Mechanical Engineers, Polytechnic University of the Philippines, Alfonso Campus, Junior Philippine Society of Mechanical Engineers, USTP Chapter, Junior Philippine Society of Mechanical Engineers, Xavier University Chapter, Philippine Society of Mechanical Engineers, Technological Institute of the Philippines Student Unit, Manila, Philippine Society of Mechanical Engineers, Technological University of the Philippines Student Unit, Philippine Society of Mechanical Engineers, Camarines Norte State College Student Unit,
Philippine Society of Mechanical Engineers, 𝐂𝐸𝐿 de Muntinlupa Student Unit, Philippine Society of Mechanical Engineers, Bicol University Student Unit, Philippine Society of Mechanical Engineers, Lyceum of the Philippines University, Cavite Student Chapter, Philippine Society of Mechanical Engineers, National University Student Unit. Philippine Society of Mechanical Engineers, Pamantasan ng Lungsod ng Maynila Student Unit. Philippine Society of Mechanical Engineers, Pangasinan State University Student Unit.
Philippine Society of Mechanical Engineers PUP Student Unit. Philippine Society of Mechanical Engineers Sorsogon State University Student Unit Sorsogon Chapter. Philippine Society of Mechanical Engineers Tarlac State University Student Chapter. Philippine Society of Mechanical Engineers University of Batangas Student Chapter. UP Geodetic Engineering Club. Philippine Society of Mechanical Engineers Sorsogon State University Student Unit Sorsogon Chapter. And a special thanks to UP Mining Metallurgical and Materials Engineering Association Incorporation.